Hi there. In the last video I went through matrix addition and subtraction, and also went through the condition involved for when you add or subtract two matrices. Okay, now in this video I'm going to go through matrix multiplication, and multiplication of two matrices is a little tricky. Okay, so it's just slightly trickier compared with addition and subtraction. So let me take a fresh piece of paper. So let me title this multiplication. Let's take a red pen and a ruler, underline this. Now, the condition for multiplication: you can only multiply two matrices if the number of columns in the first matrix equals the number of rows in the second matrix. So let me repeat. You can only multiply two matrices if the number of columns in the first matrix equals the number of rows in the second matrix. So if that is the case, so if the number of columns of the first equals the number of rows of the second, then you can multiply. So let me write down the condition. So we can only multiply two matrices if the number of columns of the first matrix, okay, is equal to the number of rows of the second matrix. So that is the condition. So you can only multiply if the number of columns of the first matrix is equal to the number of rows of the second matrix. Okay. Now, if that is the case, if you have two matrices, okay, when you multiply, you need to multiply the elements in a row of the first matrix by the corresponding elements in a column of the second matrix, and then add these results together. Okay, so let me explain by means of a general example. So for example, in the 2 by 2 case, and you know, the rule holds if this condition is obeyed. Okay, so for 2 by 2 matrices, so if I have a matrix A defined by A11, A12, A21, A22, okay, and if I have another matrix B which is defined by B11, B12, B21, B22, okay, so let me show you how to work out AB in this case. Okay, so let's check whether this condition is true for these two. So I'm calculating AB. So the first matrix is A. Number of columns of the first matrix, so I have 2 columns. And the number of rows of the second matrix B, I've got 2 rows, okay, in B. So the number of columns equals the number of rows. I can multiply these two. Okay, so I can find AB. So I'm multiplying A, which is A11, A12, A21, A22, to B, B11, B12, B21, B22. Now, supposing our answer matrix is of the form C11, C12, C21, C22. So supposing this is the answer matrix, let me show you how to work out these elements. Okay, so to work out C11, this element over here. Okay. Now, remember, when multiplying, we multiply elements along a row by the corresponding elements along a column. Okay. So I have a little trick, C11. Now, the first one refers to the row number. So I say to myself, so here's my trick, the first number refers to the row number of the first matrix. So for C11, number 1 refers to the first row of the first matrix. And the second number, this number 1, that refers to the column number of the second matrix. So the first number refers to the first row of the first matrix when you multiply. The second number refers to the column number of the second matrix. So we're multiplying row 1 of the first matrix by column 1 of the second matrix. So when I multiply the corresponding elements, we multiply in the way A11 times B11, so that's A11 B11, plus, and then A12 times B21, A12 B21. Okay, so let's work out C12. So using my trick, the first number 1 refers to the row number of the first matrix, so it's row 1. Second number 2 refers to the column number of the second matrix, so we need to multiply first row by second column. So if I multiply these corresponding elements and add, A11 times B12, A11 B12, plus A12 times B22, A12 B22. Okay? Let's continue. C21. First number 2 refers to the row number of the first matrix, so it's row 2. Second number 1 refers to the column number of the second matrix, so column number 1. So row number 2 multiplied by column number 1. So if I multiply these elements, A21 times B11, A21 B11, plus A22 times B21, A22 B21. Okay. Finally, C22. So in this case, C22, first number 2 refers to the row number. Second number 2 refers to the column number of the second matrix. So the first 2, row number of first matrix, so it's row 2, times this second number 2 refers to the column number of the second matrix. So multiplying the corresponding elements, A21 times B12, A21 B12, plus A22 times B22, A22 B22. Okay? So by conducting these calculations, you'll be working out the elements of the matrix AB. Okay? So let's use this procedure and let's take an example. Okay? So example number 1. Let me underline this. So question is to evaluate. So part A. So let's multiply the matrix 2, 1, minus 3, 2 by the matrix minus 1, 4, 0, 2. First, let's check the condition for multiplication. So number of columns of the first matrix is 1, 2, so I've got 2 columns. Number of rows of the second matrix, 1, 2. So number of columns of the first does equal the number of rows of the second, so I can multiply. Okay? So let's multiply and work out the elements of our resulting matrix. So first element, so that is C11. Okay? So remember, the first one refers to the row number of the first matrix, so it's row 1. Second number 1 refers to the column number of the second matrix, so column 1 of second matrix. So row 1 by column 1. So let's multiply. 2 times minus 1 is minus 2, plus 1 times 0, which is 0. So you should have minus 2. Okay? Second entry is C12. So 1, 2 relates to row 1, column 2. Okay? So using my idea, we need to multiply row number 1 of the first matrix by column number 2 of the second matrix. So if I multiply the corresponding elements, 2 times 4, which is 8, plus 1 times 2, which is 2, that gives you 10. Okay? Continuing forward, this element here is C21, okay? Second row, first column. So first number 2 is the second row of the first matrix. Second number 1, column number of the second matrix. So row 2, column 1, let's multiply. Minus 3 times minus 1, plus 3, plus 2 times 0, 0, answer should be plus 3. Okay? And finally, C22. So first number 2 is the row number of the first matrix. Second number 2, column number of the second matrix. Let's multiply. Minus 3 times 4 is minus 12, plus 2 times 2, which is 4. So minus 12 plus 4, minus 8. Okay? So that is the solution for the multiplication of these two matrices. Okay? So let's try another. So just one more. In part B, let's multiply 2, 0, 1, minus 1 by the matrix 1, 3. Okay? So let me show you something else. Let me show you another trick. So the dimension or the size of this matrix is 2 by 2, since I've got 2 rows and 2 columns. The dimension and the size of this matrix is 2 by 1, since I've got 2 rows and 1 column. Okay? Firstly, let me check whether we can multiply these two matrices. So the number of columns of the first matrix is 1, 2. So I've got 2 columns in the first matrix. Number of rows of the second matrix, 1, 2. So since the number of columns of the first is equal to the number of rows of the second, I can multiply. Yeah. But let me show you this trick. Now, if you ignore these two numbers here and here, so if you ignore these two numbers always, okay, you could get the dimension of your resulting matrix. So ignoring these two numbers, the dimension of the resulting matrix is 2 by 1. So we should have a 2 by 1 matrix as the resulting matrix by multiplication. Okay? So let's calculate these elements. First element is C11. Second element is a C21. So first number 1 refers to the row number, second number, column number. So row 1, column 1, 2 times 1 is 2, plus 0 times 3, 0, answer is 2. C21, first number is row number of the first matrix, which is row 2, second number 1, column number of the second matrix, column 1. Let's multiply corresponding elements. 1 times 1, 1, plus minus 1 times 3 is minus 3. So 1 minus 3, minus 2. Okay? So there you have it. Here are the examples, and here's the rule for multiplication. Okay? Now, let me also add this. So let me continue on the reverse. So let me make a note. Let's underline this. Now, in matrices, in most cases in matrices, calculating AB doesn't necessarily equal the result for the calculation of BA. Okay? So let me make a note of that. So for matrices, okay, So in most cases, AB is not equal to BA. So if you calculate AB and if you calculate BA, they don't equate to each other in most cases. Okay? However, if you do have the case that AB is equal to BA, then your matrices A and B are said to be commutative. Okay? So if AB does equal BA, then matrices A and B are commutative. Okay, so let me underline that. So those matrices are commutative if AB equates to BA. Okay? So that ends the examples on matrix multiplication. Okay? And that ends the video also, sadly. So I hope you enjoyed this video. I hope you found this video helpful.